So today we're going to continue talking about the estimation of labor supply elasticities. So the next paper that I'm going to talk about to illustrate the development of this literature is a paper by Bianchi and co-authors in the AER in 2001, which uses a very unusual natural experiment in Iceland where they happened to have 1 year, 1987, where they had no taxes at all on income. And the reason that happened is Iceland switched to a withholding-based tax system like most developed countries in 87, 88. So in 1986, so on income that you earned in 1986, you paid tax on that in 1987. So the way they were doing it before is you paid in year T plus 1 for income earned in year T. And then they switched to a withholding system so that starting in 1988, like in the US, you pay for your 1988 earnings, you pay income taxes within that year. There's withholding as you earn, right? And because they didn't want to have to tax people twice in 87, what ended up happening is that 87 income was completely untaxed. So what these authors do is use individual tax returns matched with data on weeks worked from an insurance database. And rather than using population data, which I think would have actually made the study much more compelling and you could have done a lot more, they use a random sample of 9,000 people who filed income tax returns between 86 and 88. And here, this simple graph basically shows you the main result of the paper. So this plots employment rates, and then they also look at earnings and they look at hours of work. But you see it here with employment rates. The single year in which people worked the most in Iceland was 87, which is consistent with the view that people are responding to tax incentives, right? So there's clearly trending, but there's also clearly a spike in 87 relative to other years. And then you can see how you do the usual stuff. Like, so this is just a raw time series. Even there, I think it's fairly evident that there's a treatment effect. But then you can form control and treatment groups or groups with different levels of treatment intensity by taking advantage of the fact that people are in different income tax brackets. And so they had a progressive tax system. So if you were in a high bracket before, the 87 zero tax year was worth much more to you than if you were at a relatively low level of income and you were paying low taxes, right? And so, without going into the details, they do the usual thing of computing diff and diff elasticity estimates using regressions. Here, one thing to note is that this is a very salient change, right? Not just in terms of the size of the tax change, which for many people was a very big change in the net of tax rate wage. But also, I think it was very salient because people presumably had heard of the fact that in 1987, there's no income taxes. And so it's perhaps consistent with all the other stuff that we've been talking about, that this is one of the few studies where you find very clear evidence of real labor supply effects, even on employment rates, not like taxable income shifting. Okay, so one thing, just like a technicality, in the paper, they actually report elasticities with respect to average tax rates, which is fine for the employment effects. That makes sense, but it does not make sense actually for the intensive margin elasticities, because the elasticity should be with respect to the marginal tax rate, right? And so, they're just calculating it as the change, the average change in labor supply divided by the change in the tax burden. So, so the elasticity numbers you see in the paper are not going to match what I think the implied elasticities are. So I recalculated these elasticities I used this study and various other studies in this Econometrica paper to calculate bounds, and in that context, recalculate the elasticity implied by their study, and it's about 0.37 on the intensive margin. So what you'll see is that's actually relatively high compared to most estimates in the literature, which are very close to zero, the credible estimates. And I think this ties back to the point that I'm making at the top of the slide, that this is a tax change that's actually overcoming the frictions that's getting people to respond. Now, one major issue with this estimate, which is going to relate to what we'll talk about later this lecture, is how you interpret this, this pattern here, the spike in 87. So you anticipated this with your question about whether it was an anticipated change. So you need to draw a distinction between the Hicksian elasticities that we're typically trying to estimate for optimal tax policy and intertemporal substitution elasticities, which are The idea that, I want to work more in period T instead of period T plus 1 because my wage is higher in period T. Those two things need not be the same, and we'll talk at some length about the difference between so-called Frisch and Hicksian elasticities in a little bit. And so it's not clear exactly what the study is estimating. It looks more like a Frisch elasticity, actually. Okay, so I talked about the ESA example in the last lecture, and then this paper in this lecture is a couple of pretty good representative examples of studies that have tried to use quasi-experimental methods to estimate labor supply elasticities. Now, there's sort of a sub part of this literature that focuses on estimating behavioral responses at the low end of the income distribution, because there's a lot of interest in understanding what transfer programs are doing to the behavior of low-income individuals. So we've talked about the EITC studies. This stuff that I'm going to talk about in the next few slides is related to that, but more in the traditional labor economics approach rather than the nonlinear budget set taxable income methodology. So the recent literature on this subject has focused on using the US data on the welfare reforms that occurred in the mid-1990s under the Clinton administration, and the large variety of variation that arises from that broad reform package. So what that reform did at a high level is that it modified the traditional aid to families with dependent children cash welfare program to provide more incentives to work. So the basic gist of the Clinton welfare reforms were we're going to use sort of a more workfare approach than a pure welfare cash transfer approach. And so they did a bunch of things. First, they required recipients to go to job training. So you can't just be on welfare and get the check. You've got to exhibit some effort to try to get back into the labor force. Second, this actually, I think, matters more. They limit the duration for which you're able to receive welfare. So there were strict time limits of the total amount of months you could be on welfare, even with interrupted spells. So you could take like a total of 5 years on welfare, and once you exhausted that bank, you could not get any more benefits. So there's a lot of literature. Jeff Grogger at the University of Chicago has a bunch of papers studying how these time limits affect women's labor supply behavior, because it creates interesting dynamics, right? That you anticipate there's like an option value in keeping a few months banked that you might want to use at some point, and you might want to make labor supply decisions accordingly and so forth. And so he thinks about those issues. Not going to talk about that in detail here. And then they also changed the nature of the phase out of the benefits. Rather than having a point at which you, a dollar for dollar phase out, they reduced the phase out rate to 66 cents of benefits per dollar of earnings, so that you have some incentive to earn on the margin. It's not like your welfare benefit is just being taxed away one for one, okay? Now, that's like the high-level overview of what the federal government did. There's a lot of variation across states in what actually happened with the welfare reform, which is really messy, actually. Because the way the thing was actually implemented is that the federal government gave block grants to the states, said, here's X million dollars that you can use for welfare programs. Do what you want with it, subject to these high-level guidelines. And so states ended up doing things in different ways and also staggered over time, which generates a lot of variation that people have exploited. And then, as you all know, we also had a big change in the EITC, which kind of came in to supplement the cutback in the traditional welfare program and was dramatically expanded during this period. So you had much larger EITC benefits, especially for women with kids. So the first thing that you see in the time series, which is super clear, is that the total number of families on welfare dropped dramatically from the mid-90s to the late 90s. So lots of people went off the welfare rolls. Now, in the political debate, people look at this chart and have discussed this chart, and it's tempting to kind of say, welfare reform really worked. We got a lot of people off of welfare. But that, from a logical point of view, doesn't really make any sense, because if what you did is impose a bunch of time limits and make it harder to get welfare, obviously you're going to kick a bunch of people off of welfare, right? That can't be your welfare criteria, because if it was, then you should just end welfare. Then you'd get that number to 0. So the actual economic questions of interest are what happened to, I think, two quantities. So did welfare reform actually increase labor supply? So one way to think about that is, we see this, couple million people coming off of welfare. Are these people actually working, or are they now still not working and really suffering because they also don't have the welfare transfer? Those two things have very different welfare implications, right? And so there, the literature connects to what we're talking about here. You test whether EITC expansions and changes in welfare policies affect labor supply using the types of methods that are used elsewhere in the literature. The second question, which we actually pay much less attention to, I think, in the context of tax policy than we should, is measuring the benefits of the program directly. So did removing many people from the transfer system reduce their welfare? One concrete way to think about that is, how did the consumption of low-income single moms with kids change? So that's one measure. Another measure you could think about is kids' outcomes. So now kids are growing up in families with possibly much less resources. Is that affecting how kids do in school, kids' long-term outcomes? A bunch of different things like that. I think there's been a tendency in the literature to focus a lot more on the incentive effects than on the actual measuring the benefits of these programs. We'll talk more about this in a more rigorous way in the context of the social insurance literature, but it applies equally well in the context of thinking about optimal taxation and welfare reform, in particular transfer programs. So I'll say a little bit about that in the context of a paper by Bruce Meyer in a few slides. But I think that's actually a very interesting area to do more work. And just to be clear, what I mean is not just measuring like the reduced form impacts of these systems on kids' outcomes and things like that, but tying that back to the basic model of the benefits of increasing tax rates versus the distortionary costs, and saying something about optimal policy using those reduced form estimates. I think that's where the literature is weak. Okay, so the people tend to focus on single mothers who were most impacted by the reform. So the first paper I'm going to talk about here is by Bruce Meyer and Dan Rosenbaum, QJE 2001, where they study the impact of welfare reforms in the EITC on labor supply. And they document a dramatic increase in labor force participation for single women with kids around the EITC expansion. In contrast, there's no change for women without children. So just to remind you what actually happened with the EITC here. So this diagram shows you the EITC schedule in 1992 and in 1996. And you can see that going from, if you had 2 kids, in 1992 your maximum benefit was only around $1,500. In 1996 that jumped up to almost $3,500. If you had no kids, they introduced a small EITC, but it was less than $500. So essentially no change for people with no kids, very big change for people with 1 or 2 kids, okay? And here's the key time series pattern. This is one of the most striking patterns in the recent literature on labor supply. So these are employment rates for single women with and without kids. This is just data directly from the Meyer and Rosenbaum paper. And you can see that for the women with kids, there's a dramatic surge in labor force participation rates right at the time when all these changes were occurring. When EITC was expanded significantly, when welfare was scaled back and so forth. Whereas for single women without kids, it's dead flat. Okay, so that actually looks pretty convincing that something happened probably as a consequence of these policies targeted towards women with kids. Whether that's entirely due to the EITC, ex post, I think a lot of it is due to the EITC, but you can't quite tell just from this graph because a lot of stuff changed at the same time that differentially affected women with kids and without kids as a result of the welfare reform. So we want to know whether it's the EITC incentives or the time limits that were put on welfare or the change in the phase-out rate of the welfare program that mattered. And Meyer and Rosenbaum try to get at that. They disentangle the effects of welfare waivers, changes in the AFDC, et cetera, by fitting a regression model that exploits state-level variation. And they have a bunch of policy variables interacted with number of kids and so forth. So, right, taking account of the fact that the EITC is going to affect women with 2 kids by such an amount, 1 kid with such an amount, and so forth. And then they measure all these other aspects of state policies. All of this is a bit messy because it's hard to code it properly for each person, especially given that you have measurement error and microdata on people's incomes and demographics and so forth. So that they do the best they can in terms of measuring the changes in incentives that each person faced given the state that they live in. And then you can think of it as like a big fixed effects regression with a bunch of policy changes. So it's a bit hard to figure out exactly where the identification is coming from. It's not as sharp as some of the graphs I've been showing you, but so run with it, see what you get from it. They're using now, years from 84 to 96, and they find that the extra increase in single moms' labor supply relative to single women without kids can be decomposed as follows. So 60% of that increase in labor supply that I showed you is, they think, attributed to the EITC expansion. 25% to a reduction in the maximum welfare benefits. Nothing to changes in Medicaid policy, basically. A small portion to the welfare time limits, and a small portion to changes in child care benefits and these training policies. So, what's the big picture message here? EITC seems to matter a lot, and then some of these changes in the welfare provisions seem to matter a lot. Although I think there's debate about this in the literature because, as I was saying, it's hard to disentangle exactly what's going on. You're relying on strong common trends assumptions across states for this type of strategy to work, and you can see how this can end up being a bit fragile when you change specifications and so forth. But I think it's pretty clear that EITC matters quite a bit. Just coming back to this figure, one thing I'll point out is what you find in literature is very clear evidence of an increase in the fraction of women who are working. So that is an extensive margin response. But if you plot hours of work for people who are already working, you find very little. So this is a theme that I've been talking about in the past few lectures, that on the intensive margin, using traditional diff and diff type identification strategies, you generally tend to find relatively small responses. And that's consistent with Myron Rosenbaum, Issa, Neda, Hillary Hoynes, and others have papers studying similar types of reforms of the EITC. Basically, you always find clear evidence of an extensive margin impact, but very little intensive margin impact. I'll talk probably in the next lecture about how that may not actually be a structural feature of the economy, but may have something to do with frictions. That frictions end up mattering much more on the intensive margin than the extensive margin. Okay, so that's the one example of estimating labor supply effects of transfer programs. I also want to just, as a brief aside, talk about the benefit side. So Bruce Meyer has another paper, this with Sullivan in 2004, where he looks at the impacts of the same policy changes on the consumption patterns of single mothers with kids using data from the CEX. So the question is very simple. Did single mothers' consumption fall because they lost welfare benefits and were forced to work, right? That is, you can see how if you're building a model of optimal policy, that's going to enter on the marginal utilities side, whereas the other stuff is going to enter on the elasticities measuring the distortionary cost side. Now, this is a really hard question to answer, actually, and from a data point of view is an important frontier in the field, because CEX survey data on consumption is really not very good. It's a small panel, and people are asked to recall what they consumed in the past, which they don't typically do very well. And so I think one area that hopefully we'll see some progress on in the next 5 or 10 years is using credit card data or other sources of data where you'll be able to answer this question with much, much greater precision. So they do the best they can with the CEX data. And so I'm going to show you 2 charts from this paper. So the first just plots total consumption of single mothers. Just think of it as the raw time series of consumption for low-income single moms, or they define an education cut. So women who have not completed high school, relatively low education population that's going to be affected by these welfare reforms. And what they're plotting are just total consumption rates normed relative to the sample average, or in some of these cases they're doing quantile regressions. And you can see that, what they're trying to say is there's no clearly discernible dip in the mid-90s, right? It's not like consumption fell off the charts in the mid-90s for these families. So just in the raw time series, you don't see any dramatic pattern, in contrast with the labor supply effects, actually. So then you can think about a different version of this. A natural way to think about it, given the nature of the variation, is the relative consumption of single women with kids versus without kids. So think of this as just the difference between the consumption of single mothers with versus without children, and plot that difference over time. And again, you're not really seeing, especially in the late 90s here, any evidence of a shortfall of consumption for single women with kids relative to without kids, right? So that diff and diff analysis doesn't really seem to identify much of an impact. Now, okay, so that on the face of it makes it seem like welfare reform actually worked reasonably well, because you're maintaining relatively similar levels of consumption, you're reducing distortions. That looks like a pretty good thing overall. Now, and so, I think this is generically what people find. The evidence suggests that material conditions of single mothers have improved slightly. Now, I think there's a key caveat, though, which is that the late 90s are a time when the aggregate economy was booming. And you can imagine that welfare programs matter much more when the economy is not doing well than when the economy is doing well, right? And so a very interesting question is whether, if you redid all of this analysis in the current economy, you would find very different effects. Because I think the right way to think about these welfare programs is not that they're a static thing that matter the same way in all states of the economy, but that they're providing kind of a social insurance, a social safety net, that when people's incomes fall, when they lose jobs, you rely on these systems. And so I don't think we actually really know the answer to that. In fact, anecdotally, you would think the evidence suggests that a lot of people are really in trouble now because we don't have as strong of a social safety net. And the EITC is not going to do as good of a job when you have millions of people who are unemployed, right? They're not going to get the EITC benefit. Okay, so a couple more things on these elasticities. So notice that everything I've been showing you here in the past few slides is from the more traditional labor literature, where you're looking at employment or hours of work as the outcomes, rather than the public finance stuff, which we'll come back to, which focuses on taxable income. So just a couple other highlights of this literature. One paper that I like that's more recent is by Blau and Kahn, which makes the point that these elasticities should not be thought of as stable parameters that we just plug in and are time invariant, think about policy, but rather they show quite clearly that the elasticities are changing quite a bit over time, especially for secondary earners, especially for women, right? So what they do is they identify labor supply elasticities from 1980 to 2000. So the key thing is they're going to estimate separate elasticities for 3 different periods, for 80, 90, and 2000, using a grouping instrument. So what's a grouping instrument? Rather than using tax variation, like all the other studies we've been talking about, they are going to use variation in wage rates. Now, you don't want to we know that you don't want to run OLS regression of hours of work or employment on wages directly. So suppose, to give you the intuition for this, that any one individual's wage might be endogenous, because the guy who has a really high wage might be really motivated and bargained for it and may also want to work a lot. But at a group level, let's say that fluctuations in the demand for highly skilled versus less skilled workers, that's out of the hands of any one given worker, right? And so let's assume that the labor supply curve is staying fixed, but the labor demand curve for different skill types and different types of workers is shifting around. What that's going to do is it's going to produce changes in group level wages, okay, which I can then use as an instrument for your own individual wage to estimate a labor supply elasticity. So the idea is, as in any instrumental variable approach, basically the idea of instrumental variables is I've got two sources of variation in wages, one coming from individual level choice, one coming from the group level. The individual level variation I'm going to throw out because it's contaminated. So the idea of IV is always to to throw away parts of your variation, right, and only isolate parts of your variation that you're confident are orthogonal to the error term. And here the idea is we think the group level component is plausibly orthogonal. Now you can debate that assumption as well, because maybe something was changing about these groups that's correlated with their taste that ends up affecting their labor supply. So it's not ex ante clear that that is a valid assumption, but you can see the logic for why you might take this approach, and can be quite powerful in various cases. Why do they not use occupation? So there are two things I can think of. First, I don't know if they had data on occupation. I can't quite remember. But the other thing is I can see even if you did have data on occupation, you might not want to use it because you might think that's more endogenous occupation choice than education. I mean, all of this is, there's no like theorem here, but if I think, you know, you choose a level of education and then the particular occupation you choose is a function of the wages that are offered in that occupation and your taste for work, then the grouping instrument defined on occupation is going to be problematic, whereas this won't be. Yes, yes. Ideally, you would instrument on things that are totally, like these three cuts are totally reasonable, right? Year, age, and gender are exogenous, and so that's fine. Education is endogenous, and so then you wonder if that might be sensitive to wage rates, and then that's going to mess you up. But right, that's the idea of the grouping instrument, that you don't want to cut on endogenous variables. Okay, so then how do you do it? It's very straightforward. I define these cells, they pick these cells in this case, and compute mean wages within each cell, and then I instrument for my actual wage with the mean wage of that cell. So that's a technique that's used not just here, but in many other applications. Like in this paper we're currently working on retirement savings, which we'll talk about to the end of the class. So the end of this course, we do a similar thing where we instrument for an individual's pension with the average firm level pensions. The idea being that you can't control what the firm is doing, but you might have discretion over your own individual pension. So it's the same logic of using the grouping instrument, okay? So their results, so now the idea is you've got this group level variation in 3 different decades, right, in these wage rates, and so then you can estimate separate labor supply elasticities for each of these decades, for men and women. And their main result is that the total hours elasticity for women shrank by a factor of 2 from their estimate of 0.4 in 1980 to 0.2 today. And the main idea of the paper is that women's labor supply elasticities are starting to look more like men's, prime-age males' labor supply elasticities today. That is, they're becoming inelastic, just like prime-age males. Their interpretation, which is quite intuitive, is that elasticities shrink as women become more attached to the labor force, just like men. So we think men are not very sensitive to wage rates in deciding whether they're going to work or not. As women are also, you know, generally working, that makes sense. Basically, you have fewer people on the margin of making that, of exiting versus entering, right? The density of the distribution around that point is becoming thinner for women. So I think that's useful to keep in mind because it illustrates that these elasticities are by no means structural primitives of the model that are going to stay stable. So let me summarize the static labor supply literature that we've been talking about. It's really like very, very broad. So think of this as trying to take away some of the biggest picture lessons. So we've seen that there are small elasticities typically for prime-age males. I think that's probably due to institutional restrictions that prevent a short-run response. So we, you know, connecting to the literature on friction. So my guess is we're probably understating what the true elasticities are with the traditional methods. We generally see larger responses for workers who are less attached to the labor force. So less attached to the labor force, by that I mean you're closer to the margin of being willing to quit. And so that can be on various margins, right? You might be a secondary earner. You might be a low-income individual who doesn't have a very high marginal product if you work, so you might be willing to quit, and so you see a high elasticity at the bottom of the income distribution. Or it could be an age dimension. You're relatively close to retirement. We tend to see higher elasticities there because you're again closer to the margin on a different dimension. And then the third pattern you see is that the responses tend to be driven by the extensive margin in the short run. Again, connecting to this frictions point, typical estimates of extensive margin participation elasticities are around 0.2. Intensive margin hours elasticities are now, we think, close to 0. But what those elasticities look like in the longer run, I think, remains an open question. Questions? Okay, so everything we've done until now, both in the second part, talking about the static traditional labor supply literature and the nonlinear budget set stuff, was in a totally static model. It's like people lived for one period. We estimated the elasticity using some random variation in prices, in tax rates, and that's it. Now, in practice, you can see that that's clearly not the actual situation. So you can see the problem in the approach we've been taking from the fact that all the variation we use is things like tax changes, which obviously makes sense only in a dynamic model. So something changed from period 1 to period 2, right? And then we're somehow trying to map that back to a static model where there's no notion of time. So that actually is not really rigorous. And McCurdy, in an influential paper in '81, fleshed out what the problems are with that approach. So the basic question he asks is, what parameter do reduced form regressions of labor supply on wages or taxes identify? So we're running these regressions where regressing, dealing with a bunch of econometric problems, regressing hours of work on wages, and using variation in wages over time. Is that actually identifying the Hicksian elasticity as we've been sort of loosely assuming in the static model? So McCurdy's critique is that reduced form regressions like that actually do not identify any parameter of specific interest in a dynamic model. That is, if you specify the model as a dynamic model of labor supply to begin with, as you should, because the variation you're using is coming from a dynamic environment, it's a variation over time, then what you end up estimating when you run those regressions is some mix of income effects, intertemporal substitution effects, and compensated wage elasticities, and it's not clear what that mix is. It's some weighted average of various elasticities. So what McCurdy does is he develops a tractable method, which is called two-stage budgeting, to identify preference parameters in a life cycle model of labor supply. So we're going to talk about that model. You can see this 2006 AER paper for a simple exposition of that two-stage budgeting. That's not what my 2006 paper is actually focused on, but it has a similar setup. So, okay, so here's the basic setup of the McCurdy model, or a life cycle model of labor supply, which is actually exactly the same as a life cycle model of consumption, because as we've talked about a few times, labor supply is nothing else than just a different good in a consumption context. All right, so the key assumption you make for tractability for McCurdy's thing to work is that utility is time separable. If utility is not time separable, you can't use the two-stage budgeting technique that he develops. So when you have time separable utility, you can write the utility function like this. Lifetime utility is a discounted sum of flow utilities over the periods, a function of consumption and labor. So then you get the standard optimality conditions for the choice of consumption and labor in every period. So what is the intuition for those? The marginal utility of supplying an extra unit of labor is the discounted amount times the marginal utility. And then this part is coming from the budget constraint, where lambda is the multiplier on the budget constraint, or is the marginal value of an extra dollar. And then you're going to end up equating that to the price of supplying another unit of labor or consuming another unit of leisure equivalently, which is given by the wage rate in period T discounted back to the current period. So the present value wage rate in period T. So if you just set up the Lagrangian and differentiate that, you're going to get a first order condition that looks like that, right? And it's the standard intuition. Set the marginal utility of consumption in that period equal to the price, taking into account discounting. Consumption, you get the exact same type of condition, right? Here, the relevant price, we're normalizing the price of consumption to 1. Sorry, I should have said that. So the price of consuming a dollar of the good in period T is just 1 over 1 plus r to the power T, right? Okay, so we can write two types of optimality conditions by combining these two. First, if we take if we combine these two conditions, basically bring the lambda terms over to the other side and divide, then you get this optimality condition that you want to set the marginal disutility of supplying labor equal to the marginal utility of earning, the marginal consumption utility of working that extra hour. So if I work 1 more hour, how much do I lose? I lose this amount, the u sub du dl, right? And how much do I gain? Well, I gain my wage rate times the marginal utility of consumption. So that's an intra-temporal first order condition. So think about two types of optimality. I've got to be optimizing over time, and I've got to be optimizing within a period. The intra-temporal, that is within period optimality condition, is I should be working up to a point where the extra hour that I work generates a disutility of labor that's exactly offset by the marginal utility of the consumption that that hour of work generates. And then there's an intertemporal optimality condition, which in macro we call the Euler equation, which is that I want to set the marginal utility, the ratio of the marginal utilities of consumption across periods equal to the discount rate times 1 plus the interest rate. So this just says I want to allocate my consumption across periods in a way that's governed by the relative prices and my discount factor across periods, okay? So here's the key idea of the McCurdy paper. So lambda by optimization is going to equal the marginal utility of consumption in the initial period. So if I'm optimizing this, you can think of this as a consequence of the envelope theorem. If I give you an extra dollar of wealth, you've optimized your entire consumption profile. So what's the value of that dollar to you? You might as well just spend it on extra consumption in period 0 because everything has the same marginal utility, right? Consumption in all periods. And so the marginal value of an extra dollar is going to equal the marginal utility of consumption in period 0. And so then we can write, and this is his key insight, we can write the two first order conditions in this form. We can write labor supply in period T as a function of the wage rate in period T and this marginal utility of wealth, the multiplier on the budget constraint. So why is that really useful? It's because I don't need to know the full sequence of wage rates in all other periods. I don't need to know your wealth. I don't need to know what you're consuming in all other periods. All I need to know is your current wage rate and your lambda in order to figure out how much you want to work in the current period. So basically, the reason this problem is complicated to solve is because of its dimensionality, right? Let's say you've got 10 periods. You're optimizing over 20 variables there. So generally, that won't be tractable. The way he makes it tractable is by noticing it's like sort of a sufficient statistics type of logic, that all the other parameters that end up mattering, like wage rates in other periods and the level of wealth you have, they all matter through the current marginal utility, through the marginal utility of consumption, through the lambda parameter. And so that allows me to solve the model in 2 steps, which I'll describe in a second. Okay? So the key intuition you want to grasp here is that current labor and consumption choices depend upon the current price, the current wage, and the marginal utility. And all other wage rates and initial wealth only enter through the multiplier on the budget constraint. So that's really easy to see for the case of separable utility. Separable now, I mean not time separable, but separable across consumption and labor. So suppose I can write U of C comma L as U of C minus V of L, okay? Then the optimality condition for labor is going to be that I set the marginal disutility of labor equal to lambda times the wage rate in discounted form. So this is just the intratemporal optimality condition that we had before, right? All I'm doing is writing this out with this particular functional form. And then that means that I can write the labor supply in period t as just take the inverse of this, right? So the inverse of V prime. I can write labor supply in period t as V prime inverse of this function. And notice that the only things that enter that function are lambda and WT. Lambda and basically the relevant price, okay? So that's the point I'm trying to make, right? The only thing that matters is lambda and the wage rate, and you can see that directly in this example. Okay, so that sufficiency of lambda is going to greatly simplify the solution to the intertemporal labor supply model and turns out to generate notions of elasticities that have been widely applied in the subsequent literature. So the concept that McCurdy develops and is widely applied is that of a Frisch intertemporal labor supply elasticity. So this is like the elasticity that actually comes out most naturally in a dynamic model of labor supply. So call it delta. This is the usual DLDW. So it's like how does a 1% change in the wage affect labor supply? But here we're going to hold lambda constant rather than the other notions of elasticities that we've talked about, where in the case of the Marshallian elasticity, what are we holding constant? We're holding constant your total, your unearned income. Okay, so we're changing wages and allowing you to have income effects. And then the Hicksian elasticity, we're holding total utility constant. In this case, the way he's thinking about it is I'm going to keep this term fixed and change the wage rate. And what is the elasticity that generates? That's what's called the Frisch elasticity of labor supply, and we'll talk about how you interpret it. One more thing while we're on this slide that I want to point out is that lambda equals a marginal utility of consumption period 0, right? If you have separable utility like this, the marginal utility of consumption in period 0 is purely determined by the level of consumption in period 0. So if I have posited a particular utility function, if I tell you that you are consuming 2 units of the good, you know what the marginal utility of consumption is. And so the consequence of that is if I want to estimate what's called a lambda constant labor supply function, that is the effect of a change in the wage rate on labor supply holding lambda fixed, that's the same thing as saying what's the effect of changing the wage rate holding consumption fixed. Because consumption is the only thing that determines marginal utility. Okay, so what we're trying to do here is estimate this Frisch elasticity of labor supply. I'll explain why in a second. And the point is, all you need to know is you're trying to estimate DLDW holding lambda fixed, which is the same thing as estimating DLDW holding consumption fixed. Okay? So what does this Frisch elasticity correspond to in the real world, and why do we care about it? So the experiment that corresponds to this parameter here is changing the wage rate in a single period, holding all other wages and the consumption profile totally constant. So it's like if I change your wage rate for an epsilon unit of time, okay, so this has hardly any impact on your total income, and let's assume, and it has no impact on the path of your consumption. How much extra do you choose to work in that period because your wage rate is temporarily higher, even though you're holding fixed your consumption profile? That's what the Frisch elasticity of labor supply captures. The idea here, what this is going to be relevant for actually, and the reason it's used a lot in macro, is that it matters for business cycle fluctuations. So in a real business cycle model where you have wage rates fluctuating over time, and that's what's generating fluctuations in labor supply, if people are optimizing, so they know their wage rates are fluctuating over time, that wage rates, the wage fluctuations are totally anticipated, then my consumption profile is not going to change. It's like I know I'm going to be earning, let's say there's no uncertainty. I know that I'm going to be earning more tomorrow than today. If I'm a life cycle optimizer, my consumption path is not going to change as a result of that, right? I've already optimized my consumption over my entire life, knowing the path of wages that I face. And the Frisch elasticity is saying, how much does my labor supply change when my wage rate is fluctuating across periods, holding the consumption path fixed, which if you take a pure real business cycle view of the world, is the elasticity that's relevant for figuring out how much labor fluctuates over the business cycle, okay? So you can show, McCurdy proves this in his paper, that delta is greater than 0. So that's very intuitive. You're going to work more today to take advantage of a temporarily higher wage. It's trivial to establish that in the separable utility case like this, where we know that we can write labor supply as V prime inverse of this here, and then you can differentiate that holding lambda fixed. So take the partial derivative holding lambda fixed. And what you end up getting is this equation here, which is a function of V prime prime in the denominator, because that's the inverse there. And all of the parameters in that equation are positive, because that multiplier is going to be positive, and all of this is positive. This is a convex function, convex disutility of labor, so V prime prime is going to be positive. So you know that when wage rates go up, you're going to work more in the current period when I hold lambda fixed. Remember, that doesn't have to be true with the Marshallian elasticity, right? When I raise wage rates, you might work less because of the income effect. So in the Marshallian elasticity, I raise wages. There's both an income effect and a price effect. It can end up being that the income effect dominates the price effect, and that elasticity could be negative. That cannot happen with the Frisch elasticity if you're optimizing, right? Okay, so let's be more concrete about the types of wage changes that are generating these different elasticity concepts. And this is where I think actually the McCurdy exposition is most useful. So he distinguishes between 3 types of wage changes: an evolutionary wage change, which is a movement along a wage profile; a parametric wage change, which is a temporary change; and a profile shift. So let me show you this graphically. So let's say you're following a guy over time, all right, as he's, let's say it's age on the x-axis here. And wage rates follow a certain path. Typically, they're hump-shaped if you look at the data. Wages are low when you're young. They go up, and then they tend to come back down. 3 different types of wage variation that one might see in the data that are going to generate 3 different elasticities. The first is what he calls an evolutionary shift, which are movements along the wage profile. Okay, so this is saying one way I could estimate an elasticity, one way I can generate variation in W, is by comparing a guy when he's 45 versus when he's 40. And so this is like related to what we were just talking about. He's got a given consumption profile. He's decided in a perfectly, in a model without credit market imperfections, he's got some fixed consumption path. He knows his wage rate is higher when he's 45 than when he's 40. He may want to work more when he's 45 than when he's 40. That is going to be identified by the Frisch. That's going to identify the Frisch elasticity, and it's going to be governed by the parameter that controls the Frisch elasticity in the utility function. A second type of change is a profile shift in the entire schedule of wages. So this is saying, this is how I think about a permanent tax cut. So suppose in this regime I face a tax rate of 20%, and in this regime I face a tax rate of 40%. McCurdy's main point, the main, I think, takeaway message is when you have a permanent tax change, which is perhaps what's of greatest interest if we want to understand how tax policy is affecting the economy in the long run. That type of variation is this profile shift, right? That is different from the variation along the profile, and it's also different from what he calls a parametric change, which is a temporary change in the wage rate in a single period. That's like the Iceland experiment. Think of this as the Iceland experiment, where I change the wage rate in 1987, but not in any other period. Okay? And his point is, when you run a reduced form regression, you're kind of using all of this different variation, and it's not clear what elasticity you're identifying, which I think is exactly right. whether you think there are credit market imperfections or not, it's clearly correct that the type of variation that you use to identify the elasticity could end up producing very different elasticity estimates and may not correspond to this permanent shift, which maybe is what you're aiming to identify, okay? And so the way he thinks about the problem is if I specify this dynamic life cycle model of labor supply, I can structurally estimate its parameters, and then I can calculate whichever elasticity you want. I can calculate the Frisch elasticity, I can calculate this elasticity, I can simulate all these different experiments. But the other way to think about it, even if you don't buy that structural approach, is you want to think about how the nature of the variation you're using for identification corresponds to some parameter that you do or don't want to identify. Okay? So there are some identities which you should be aware of that connect the various elasticity concepts, which are useful. So the first is, these are just mathematical identities given the structure of any time-separable utility model, of a life cycle model. So first is that the Frisch elasticity is greater than or equal to the compensated static elasticity. Let's come back to this diagram. Frisch elasticity is either movements along a given wage schedule or the temporary, very short-term change, which essentially has no effect on the consumption profile. That's the way to think about it. The compensated Hicksian elasticity, the static elasticity, is the parametric shift in the wage and then compensated so that your income doesn't change. So that's the Hicksian experiment, right? Okay, so mathematical result one that you can show is that the Frisch elasticity is bigger than the compensated static elasticity. The second identity you can establish is that the compensated elasticity is greater than or equal to the uncompensated elasticity, which is just the effect of the wage change in this diagram without the income compensation. So we, okay, so the first inequality is due to intertemporal substitution. Intuitively, when I raise the wage in only one period, like in Iceland only in 1987, I have two things going on. First, I have an incentive to work more like in the standard static model, like in any other year, right? Like as would have occurred if I had raised wages in all years. But second, I have an incentive to work in 1987 and save money, which I then use in 1988. So I have an incentive to shift labor supply from 1988 to 1987. And so as a result, you can see why it's intuitive that the Iceland 87 experiment might generate an elasticity estimate that is bigger than what you'd want to use to calculate the deadweight cost of taxes, right? Because if I permanently change taxes in Iceland, I may not see such a big increase in employment rates. So that makes sense, I think. The second inequality should be familiar to you. That's just the Slutsky equation. So the second inequality is due to income effects, right? The compensated elasticity is the pure price effect. The uncompensated elasticity, when I raise wages, you also feel richer. And so you want to work less as a result of feeling richer. And so that's going to generate a smaller elasticity than if I have just the compensated variation. Okay, so those are two identities. When do you have these elasticities being equal? So what is the case where you actually don't have to worry about this stuff? It's the case where utility is quasi-linear. So what he also establishes is when you have no income effects, all of these three elasticities are identical. And if not, the inequalities are strict. So what's the intuition for that? Of course, if you have no income effects, the uncompensated and the compensated elasticity are going to be the same because they only differ because of the income effect. The Frisch elasticity and the compensated elasticity end up looking the same because think about if you have a quasi-linear utility function, you don't care when you consume, okay? So there's basically no intertemporal substitution motive because there's no reason to save. In every period, you want to consume, so suppose your utility function in period t looks like this, right? So quasi-linear. In every period, you're simply going to consume up to the point where the marginal disutility of labor equals the wage in that period. You don't bother saving money for other periods, the problem becomes totally separable across periods because you don't have diminishing marginal utility of consumption. So there's no reason to stock up in one period to be able to consume in the next period. In each period, you solve a separate problem. And so as a result, again, the Frisch elasticity ends up being equal to the compensated elasticity. So the thrust of his critique is that, in fact, we think there are probably income effects. That is, the utility function has some curvature, and that's going to that really muddies the water with the traditional reduced form elasticity estimation. Okay. Now, the other thing to note here, which you guys have picked up on, is that the difference in these elasticities is fundamentally related to whether the variation you're using for identification is anticipated or unanticipated, and how long that change lasts. So the way I think about it is, if you have an unanticipated permanent tax change, that basically is the experiment you want to identify the static Hicksian elasticity. Because that's a case where you had no scope for intertemporal substitution, and the tax change lasts forever from that point. If you have an anticipated change, like the Iceland thing, then you have scope for intertemporal substitution. Or if you have a temporary thing where I raise taxes in 93, let's say, and cut them in 94, then of course you have scope for intertemporal substitution. So one of the, I think, key insights that comes out from McCurdy's paper is that you need to understand what people's expectations about tax policy are in order to know what elasticity you're identifying, which is actually pretty complicated, because you need to have a sense of what people think the duration of that tax change is going to be in order to get this exactly right. Okay, now one last identity relating these elasticities, which actually turns out to be quite useful, and for reasons I don't fully understand, people haven't really appreciated, I think, in the literature. So this is a result established by Martin Browning, which shows how the Frisch elasticity is related to the Hicksian elasticity and other parameters. So sorry, I should have been clear on what the notation here is, but just write this down in your handouts. This is the Frisch elasticity on the left side. Epsilon here denotes the Hicksian elasticity, okay? The compensated elasticity, static elasticity. Rho is the elasticity of intertemporal substitution of consumption. And then there are two other parameters. It's actually useful to know what these are because they're commonly used in labor economics. One is dWL dy. Okay, y in the notation of the model is unearned income. And dWL dy is sometimes called the marginal propensity to earn out of unearned income. So what does that mean? If I give you $1, how much do you change your earnings? We usually think that number is going to be less than 1. Like if I give you $100, it would be surprising if you cut back your earnings by $100 and leave yourself in the same position. But we think that that number is greater than 0. That's what the income effect is, right? If I give you a ton of money, you might want to earn less because you have more cash. And so this measures the size of income effects in an intuitive way. And then this is just the ratio of assets to your earnings. So think of this as how many multiples of my current earnings am I maintaining in my bank account? And this actually relates to your question about credit market imperfections. So in the data, the observed value of A over WL is far, far lower than you'd predict in an optimizing model. So in an optimizing model, people should be saving quite a bit, or in a sense, like they have a lot of accumulated capital so that they can smooth consumption, right? In practice, people don't have any money. Most people have no savings, essentially. And that really kills off the intertemporal substitution channel, which I'll come to. In any case, so in the life cycle model, this is a mathematical relationship between the Hicksian elasticity and these other parameters. So what I think has not been appreciated is that that actually puts a pretty tight bound on how different the Frisch and the Hicksian elasticities can be in practice. And so I want to show you that with this table, which is taken from the year, this is the 2012, this is the Econometrica article. So all this table does is calibrates what the implied Frisch elasticity is for different values of the other parameters. So I'm going to take a Hicksian elasticity of 1/3, which is what I end up estimating in that paper. We'll talk about that later, after accounting for frictions. And the point I was trying to make with this table is that I focus on estimating the Hicksian elasticity. Macro guys are also interested in the Frisch elasticity, but the Frisch elasticity can't be that much bigger than the Hicksian for plausible parameters. So here's how you see that. So take a Hicksian elasticity of 0.33, and then vary two things. The elasticity of intertemporal substitution, which there's a separate macro literature on, where there's some disagreement about what that parameter is, but I don't think anybody thinks that elasticity is bigger than 1. Okay? So take that as an upper bound. And then the other upper bound that I use is vary the size of the income effect. I think most people think the uncompensated elasticity of labor supply is either 0 or positive, meaning when I pay a guy more money, when I increase his wage, he ends up working more, not less. We usually think that when wage rates go up, people don't start to work less, okay? And that ends up putting an upper bound on how big the income effect can be relative to the price effect. In particular, you know that if you have a price effect of 0.33, you cannot have an income effect of more than 0.33. Otherwise, when you raise wages, you would be cutting, you would see labor supply falling. So take that as an upper bound on the size of the income effect, and then you can apply this formula, and you end up seeing that if the Hicksian is 0.33, the Frisch is bigger, as we know has to be true, but it's only 0.47. It's not like it's 5 times bigger, right? That's not possible. And why is that intuitively? It's because the difference between these two elasticities is second order. That is, it's related to the income effect squared. It's a second order function of the size of the income effect. So unless income effects are enormous, you can't have huge differences between the Frisch and the Hicksian elasticity, which is kind of useful from an applied point of view, because it means that the bottom line of this is that while you do want to think, conceptually about the type of variation you're using, even if you're mixing some of these different types of variation, a weighted average of these elasticities are relatively close to each other, right? So even if you end up identifying the Frisch, it's going to be relatively close to the Hicksian and vice versa. Okay, so weighted average of a bunch of numbers that are similar to each other is going to be close to all of them. That's basically the point of this exercise. Yeah.
So if I can reduce my consumption today to save for tomorrow, or I could, tomorrow just increase my my labor and earn more, you would think that the intertemporal elasticity of substitution for consumption and then the Frisch elasticity of labor would be similar, no? Like, I don't see why these two.
Well, I mean, that's part of what this equation is saying, right? It's saying they're
right,
related.
Yeah.
So it's saying the higher is rho, the higher is the Frisch elasticity. That captures your intuition. No, but it's not clear that they should be literally the same. Well, because any elasticity is basically governed by how convex, by the curvature of the relevant utility function or the relevant objective function. Okay, so the extent to which I'm willing to substitute consumption across periods depends upon how curved U of CT is. If U of CT looks like a straight line, so it's quasi-linear, then I'm perfectly happy to substitute consumption across periods. I don't care. If it's very curved, I'm less willing to substitute. So the rho is determined by the curvature of U of CT. The intertemporal elasticity of substitution of labor is determined by the curvature of this thing, psi of LT. So I could be in a situation where I'm very happy to consume a lot tomorrow instead of today, but let's say working gets really hard for me if I work more than 40 hours. Like, I find that super costly. So then I'm going to be totally unwilling to substitute from, a number of hours of work, but I might be very willing to substitute in when I consume. So those two things, they're determined basically by different curvatures, so they need not be the same. But your intuition is also right that if I'm more willing to substitute on one, then I should be more willing to substitute on another. The way you can see that is if the rho is 0, that is, you're totally unwilling to substitute across periods, then you're back in the static model, basically. There is no intertemporal linkage. And then the Frisch equals the Hicksian exactly. Okay. All right, so what have people actually done with this to take account of these problems? So McCurdy, as I was saying, structurally estimates this life cycle model using panel data for men and within-person wage variation. So this is very much in the view of I've specified the model correctly up to the error term, which I'm going to assume is orthogonal to other things like labor supply. And then once I've done that, I have in the panel wage variation naturally, like as a person gets older, wages go up and so on. And so then if you take, you can maximum likelihood fit that model to the data, and you get estimates of the Frisch and compensated wage elasticity of around 0.15. He actually finds that the income effects are not that big in his initial application. Now the key limitation of that approach is that the wage variation is not exogenous, right? So what's the kind of thing that goes wrong? As wages change over the life cycle, what the model is saying is nothing else is changing, but maybe your taste for work change or the number of kids you have changes or who knows what else changes. That's not allowed and that would bias the estimates. Pencavel has a subsequent paper where he uses some instruments to re-estimate McCurdy's model and then gets estimates of the Frisch elasticity that are larger than the uncompensated wage elasticity. But again, here I think it's not totally clear if the instruments are valid and what exactly is going on. So I'm going to focus instead on a couple of other papers which I will get to. But let me first mention this, which relates to the question about perfect capital markets. So Card has a well-known paper in '91 where he critiques the value of this way of thinking about the problem, as opposed to the simple static labor supply model. So he makes 3 points. First, he argues that this approach, you would think the first order thing it should do is explain the variation in how much people work over the life cycle. But in fact, and so what it predicts is that if you have this hump-shaped pattern in wages, you should see a very similar hump-shaped pattern in hours. In fact, you don't, because hours look much, much flatter than that, all right? And so Card's first point is just that people don't seem to be behaving consistently with intertemporal optimization in this way when they choose labor supply. Second, he argues that if you really care about these profile shift elasticities, which from a public finance point of view may be the most important, like for measuring the deadweight cost of taxes, then it's not clear that you need the whole intertemporal framework as long as you get the right source of variation, if you get the profile shift variation. And then the third point he makes, sort of to cast it loosely, is that it's difficult to identify the key parameters of the model because you've got so many different things to identify now. It makes the whole empirical problem much more complicated, possibly without much net benefit. So, despite that critique, I think people have made some progress in implementing this and gotten interesting estimates. So I'm going to talk about 2 papers. The first is a paper by Richard Blundell and Kostas Magir and Alan Duncan in Econometrica in 1998. So what I like about this paper is there are a bunch of ITLS papers that use a structural approach where you can question whether they're actually estimating the elasticities of interest. And then there's the huge reduced form literature. This paper is kind of between the two in an interesting way. So they use quasi-experimental variation that's kind of like a grouping instrument approach, coupled with equations derived from the McCurdy type of intertemporal labor supply model to rigorously identify the Frisch elasticity as well as the other elasticities. So specifically what they do is they group individuals, in this case by birth cohort, interacted with education. And then they take advantage of the fact that there were a series of tax reforms in England in the 1980s that affected these groups very differently. And okay, so that up to there looks like the reduced form studies we were talking about before. But then the key innovation is that they also use consumption data and they use that as a control for permanent income. So remember what I was saying earlier about how lambda, the marginal utility of consumption, is determined purely by the level of consumption. So they estimate a model where they're regressing labor supply on wages, controlling for consumption, and then they can interpret the elasticity that they get as the Frisch elasticity, right? So think of it as running log LIT on A plus B log WIT, but now, so that's what the reduced form studies would have done. But then I include this thing here. Okay, so that's holding consumption constant. That's a parametric way of holding consumption constant. And so then this B ends up being the Frisch elasticity in their estimation. That's essentially what they're doing. Okay? And so what they're going to get is a structurally interpretable elasticity estimate that's identified off of quasi-experimental variation. So here are the coefficients you get from that regression. So they do this for a bunch of different groups. So like in this table, it's cut by the number of the age of your youngest child. And so you can see like for some groups, so for people without kids, they end up estimating a wage elasticity that is what I'm showing you. So no, this is the wage elasticity. So this is the uncompensated wage elasticity, and this is the compensated wage elasticity. So the way to think about this is, once I estimate the Frisch elasticity, and I've estimated the size of income effects, I can calculate all the other elasticities using the types of identities that I was showing you. Okay. And so here they're reporting the uncompensated and compensated wage elasticities. And you can see that in some cases, the income effects are non-trivial. They're getting elasticities in the range of like 0.2 to 0.4, roughly, okay? Which is consistent, I think, with the broader view of what people have, the size of these elasticities. For many groups, they find virtually no income effects. As in any other study, there's an identification assumption in the background, which is common trends, in this case, across the relevant groups. One thing that's useful in their paper, which is generally useful in these diff and diff type studies, is when you have reforms that go in opposite directions. So one case where the taxes went up for one group and another case where they went back down. That is useful because that deals with the problem that there just might be secular differential trends. So concretely, what's the thing we worry about? In the 80s, there was widening there was skill-biased technical change, so there was widening income inequality, right? So if you have a tax cut that's always in the same direction, like you're always cutting taxes for the higher income guys, you are going to falsely conclude that the elasticity is bigger than it is. And you might never realize that. Whereas if you had tax changes going in the opposite directions, one where taxes went up for the high income guys, and then a second case where taxes went back down, you wouldn't, you'd have different biases in the different cases, right? And so you would start to figure it out. So that it's useful when you have variation going in opposite directions in the diff and diff, which they actually have here. A more recent study, which I think is very clear in terms of identification and ties nicely to the Frisch elasticity concept, is this paper by Manoli and Andrea Weber, Dave Manoli and Andrea Weber, where they use variation in retirement benefits as a function of job tenure in Austria to estimate an intertemporal substitution elasticity. So here they have excellent data. They have an administrative panel for the full population of Austria in 1980 to 2005. And the question they ask is directly related to estimating a Frisch elasticity. How much do people delay retirement in order to get higher anticipated benefits? So this is a case where I know what the retirement pension benefit schedule looks like from the beginning. If I'm optimizing, I'm going to have some consumption path that I pick. And then the labor supply that I choose is going to be totally governed by the Frisch parameters, right? Because nothing is changing in an unanticipated way. And they get a rough estimate of the elasticity of around 0.2. So let me show you how this works. So turns out that in Austria, you get a severance payment when you retire. So you just get a lump sum payment when you retire, in addition to pension benefits. And the size of that severance payment depends upon how many years you've worked prior to that point. And it's a step function. So if you worked for more than 10 years, you get 1/3 of your last year's salary. If you worked for more than 15 years, you get half, and then so forth. And then there are these other steps. Okay. So now you can use a standard bunching or regression kink type of estimator where it's very straightforward. You just plot the distribution of tenure at retirement. So how many people retire in each of these different buckets relative to the cutoffs, right? And you can see that there's a spike in retirements after each of the thresholds. And there's a shortfall before, exactly as you'd expect, right? So people are choosing to delay retirement because the way to think about it in the context of the intertemporal labor supply model is that your marginal wage rate is becoming extremely high at this point, right? The value of sticking around for an extra couple of weeks is super high. And in fact, it's so high that the puzzling thing in the data is not that you see these spikes here, but that you see anybody retiring here. So for a long time, Day and Andre were trying to fit a model of intertemporal substitution to these data and ended up never really working because what the model wants to do is have this like zero mass here, right? Because your wage rate is incredibly high at that point. And so then there's a question of why people are still retiring at that point and so forth. But you can see at least the basic concept of intertemporal substitution. And you can see what I was saying earlier, tying back to the Hicksian elasticities. The extent of substitution you may see from this, let's take the extreme case, like the week before the cutoff to the week after. I might see a lot of substitution. And maybe I get a very high elasticity. That doesn't necessarily mean that if I raise tax rates forever, I would see a similarly high elasticity, because that could be a very different parameter, right? I might not care if I work a lot more today relative to tomorrow, but I might not want to work more forever if taxes go down. And so that's, I think the main point here that you need to think about that. So